Ozone generation versus AOP systems for residential pools. First, technology overview. Ozone generation systems. Ozone, O3, is produced either by passing air over a UV light or via corona discharge, a small lightning arc in a chamber. The generated ozone gas is injected into the pool circulation line using a venturi injector or similar device. Once dissolved in water, ozone is highly unstable and reacts with contaminants, breaking back down into oxygen. Ozone units are typically installed after the filter and heater and set to run when the pump runs, often wired with the circulation pump, to ensure ozone is introduced only during water flow. For example, CMP's DEL ozone systems use advanced plasma gap corona cells to produce ozone, which is then fed into the return line. These systems are supplemental sanitizers working alongside the primary sanitizer in the pool. AOP hydroxyl radical systems. AOP stands for Advanced Oxidation Process. In pool applications, AOP systems combine ozone with UVC light to produce hydroxyl radicals, OH. When ozone gas and UV light interact, hydroxyl radicals, one of the strongest known oxidizers, are generated almost instantly. AOP units are often all-in-one devices containing both an ozone generator and UV lamp in a single housing. Water passes through the unit, either via a bypass loop or full-flow treatment chamber, where ozone is injected and immediately exposed to UV, creating a powerful oxidative reaction before the water returns to the pool. For instance, CMP's next-gen AOP units integrate APG ozone cells, a UVC reactor, and an injector manifold in one compact unit. Like ozone-only systems, AOP is used as a supplemental treatment to enhance water quality in conjunction with a residual sanitizer. Integration in residential pools. Both ozone and AOP systems are added to the pool's plumbing on the return side. AOP systems may require slightly more plumbing, electrical integration due to the combined equipment, but modern designs aim for plug-and-play installation. Many residential units, ozone or AOP, are designed for easy pad or wall mounting and can treat common pool sizes, e.g. up to 25,000 gallons, with relatively small footprints. The Fluidra CM PAOP systems, for example, come in models like the AOP 25, side stream for up to 25,000 gallons, and AOP 40, full flow for larger pools. Зрение, в то время как только озонные единицы, такие как DEL Ozone 25, размеры подобны для средних по размеру бассейнов. In summary, ozone generators produce ozone gas to oxidize pool water, while AOP systems take it a step further by using ozone and UV together to create even more potent hydroxyl radicals. 2. Chloramine removal and overall sanitization. Chloramine reduction. Both ozone and AOP excel at breaking down chloramines, combined chlorine compounds that cause odor and irritation. Ozone is a very powerful oxidizer that destroys chloramines much faster than chlorine alone can. Pool ozone systems have been shown to eliminate pool smell and eye irritants by oxidizing chloramines and other byproducts. AOP systems go even further. The hydroxyl radicals generated are even stronger oxidizers, virtually ensuring any chloramines that pass through the system are destroyed. In fact, AOP is noted to prevent chloramine formation and eliminate the associated odors and irritations, dramatically improving water clarity and comfort. Multiple studies and industry reports document that supplementing a pool with ozone, or AOP, leads to near-zero chloramine levels and better air quality, especially important for indoor pools. Residential outdoor pools typically have less chloramine buildup than indoor pools. UV from sunlight naturally breaks them down. But heavy bather loads or organic contamination can still produce chloramines. In these cases, ozone or AOP can quickly eliminate them. Sanitization and oxidation of contaminants. Ozone and AOP systems are effective at neutralizing a broad range of contaminants. Ozone is known to destroy bacteria, viruses, algae spores, and organic compounds on contact in the circulation system. It can even break down stubborn contaminants that might take chlorine much longer to oxidize. AOP's hydroxyl radicals have an even higher oxidation potential, meaning they can inactivate or oxidize 99.99% of pathogens and impurities that flow through the unit. For example, advanced AOP units have been certified to kill 99.9% of bacteria and viruses, including chlorine-resistant parasites like Cryptosporidium when sized properly. While chlorine in the pool handles disinfection in the bulk water, these systems provide an extra boost by rapidly killing or breaking down contaminants during circulation. They also oxidize lotions, sweat, urine, and other organics that enter the water, which helps prevent the formation of disinfection byproducts like trihalomethanes and keeps water clear. Synergy with chlorine. Ozone and AOP are intended to work in tandem with chlorine or another primary sanitizer. By tackling the bulk of oxidation tasks, they lessen the workload on chlorine, allowing a lower residual level to effectively maintain sanitation. Studies and field reports show that adding an ozone or AOP system can significantly reduce the amount of chlorine needed to maintain safe water. For instance, AOP can oxidize organic matter in seconds that would take chlorine days, meaning the chlorine-free residual remains available longer for killing new germs. AOP in particular helps chlorine work better by aggressively breaking down chloramines and other intermediates. Pool owners often find that with ozone or AOP, they can run at the lower end of the recommended free chlorine range, yet still have sparkling, odor-free water. Additionally, if a saltwater chlorine generator is used, an AOP system can extend the cell's life by reducing how hard it needs to work. Essentially, you get more chlorine output efficiency when an AOP or ozone system handles most oxidation. Important: neither ozone nor AOP produces a lasting sanitizer residual in the pool, so a minimum level of chlorine or bromine must be maintained in the water to continuously disinfect areas the circulation system may not reach. Third, installation and maintenance. Equipment and plumbing requirements. Installing an ozone generator generally involves adding a T and injector manifold into the return line, plus mounting the ozone unit, usually a box the size of a small cabinet or wall unit, nearby. Many residential ozone units are plug-in, 110 volts or 240 volts, and use a venturi injector to draw ozone gas into the water. They often include a check valve to prevent water backflow into the ozone generator. AOP systems combine UV and ozone, so they typically have two connection points, inlet and outlet, for water to pass through the unit. Depending on design, an AOP unit might be plumbed in line, full flow, or in a bypass loop, side stream. For example, CMP's AOP 50 is a full flow unit with 2-inch unions, certified for approximately 50 gallons per minute flow. Whereas the smaller AOPS 25 uses a 3/4 inch side stream loop at approximately 20 gallons per minute. Adequate flow rate is important. Running a variable speed pump too low can cause ozone bubbles to not fully dissolve, leading to gurgling at the returns. Manufacturers like CMP often provide diagrams for proper placement, usually after the filter and heater and before any chlorinator. Space-wise, both systems are compact. A combined AOP unit may be slightly larger or heavier due to the UV reactor. Electrical requirements are modest. Ozone or AOP units typically draw on the order of 0.3 to 0.6 amperes at 240 volts, under 150 watts. They should be wired such that they operate only when water is flowing, often tied into the pump's timer or a flow switch. Maintenance tasks. Both ozone and AOP systems require periodic maintenance to ensure they operate effectively. Ozone generator, corona discharge cells or ozone chips will degrade over time. Depending on the model, these might need replacement every few years or after a certain number of operating hours. Some systems have indicator lights or alarms when ozone output drops. If the unit uses an air dryer or filter, that filter media must be replaced or regenerated per instructions. It's also important to occasionally inspect and clean the injector for any calcium buildup or debris, as a clogged injector can reduce ozone delivery. UV lamp. For AOP, AOP systems have UVC lamps that typically need replacement about every 1 to 2 years, after approximately 9,000 to 10,000 hours. Over time, the UV output diminishes even if the lamp is lit. Replacing the bulb ensures the AOP system continues to produce hydroxyl radicals effectively. Cleaning the quartz sleeve around the UV lamp, if the design has one, is another maintenance item. Mineral scale or dirt on the sleeve can block UV. CMP's AOP units are designed with easy top access to the UV lamps for this reason. Other parts, both systems have tubing, check valves, and possibly a Dega vessel. Tubing and seals, O-rings, should be inspected for cracks or wear each season, as ozone can stiffen some plastics, shine rubbers over time. Ozone-resistant materials like silicone and ozone-rated O-rings are used, but still check them. If an optional mixing Dega vessel, MDV, is installed, it contains a carbon off-gas filter that may need replacement to maintain effectiveness at destroying excess ozone. Troubleshooting. Common issues include the ozone generator not powering on, check power supply or interlock, no flow-through injector, check for clogs or proper pump speed, or alarm indicators on advanced systems. A drop in ORP or rise in chloramines can also signal the ozone AOP isn't functioning fully. Many units have clear tubing or a viewing window to confirm ozone bubbles, or a glowing plasma cell UV lamp as a quick visual check. Manufacturers like CMP provide support and parts lists, e.g. replacement ozone modules, tubing kits, UV lamps, to help resolve issues and keep the system running. Installation considerations. Safety devices like a flow switch, interlock, or vacuum pressure switch are often built in or recommended to ensure ozone doesn't flood the line when the pump is off. As noted, water flow must be sufficient. If using a variable speed pump, one might need to program a minimum speed when the ozone AOP is active, or use a bypass loop. Also consider plumbing materials. PVC is generally fine, but avoid inserting ozone upstream of any component that could be sensitive. E.g., some pool covers or liners can be degraded by high ozone if it were to accumulate, though this is rare in outdoor pools with proper installation. In terms of user interface, most ozone AOP units run automatically. The homeowner's role is mainly to monitor indicator lights and schedule the aforementioned maintenance, lamp or cartridge changes, typically annually or biannually. 4. Safety considerations. Chemical and off-gassing hazards. Ozone gas, while beneficial in water, is hazardous to breathe in concentrated amounts. Fortunately, ozone's half-life in water is very short, and it reverts to oxygen. So when properly installed, there should be minimal ozone off-gassing at the pool. Industry standards mandate that ozone generators for pools be used only with sufficient ventilation and measures to limit ozone in air. The OSHA permissible exposure limit for ozone gas is 0.1 parts per million over 8 hours. And pool systems are designed to stay well below this. Dissolved ozone in water is not harmful at the low levels used. To ensure safety, many systems use a mixing Dega vessel that strips out undissolved ozone gas before the water returns to the pool, venting the ozone through a carbon destruct filter. This prevents bubbles of ozone reaching the pool surface. In outdoor residential pools, any tiny amount of ozone that might escape in the return water will dissipate in the open air quickly. Still, installers should heed manufacturer guidelines. For instance, CMP recommends an MDV if using their ozone AOP unit with a variable speed pump on very low speeds. The Reddit example of a homeowner noticing gurgling bubbles with a CMP AOP system highlights this. The CMP rep noted this air removal filter is available for those who prefer no bubbles in the pool. A properly tuned system, or slightly higher pump speed, and/or an MDV can eliminate that issue. Handling and operational safety. One advantage of ozone AOP is that the pool owner is not storing or handling additional hazardous chemicals. Ozone is generated on demand from air or oxygen. However, the equipment itself is electrical and should be installed following electrical codes. GFCI protection, proper grounding. UV lamps contain a small amount of mercury. If a lamp breaks, one should carefully ventilate and clean up according to the lamp manufacturer's instructions. Avoid skin contact with fragments. Always shut off power before servicing an ozone or AOP unit. For ozone units, avoid touching the corona discharge element as it can be hot and is high voltage when operating. All ozone systems should include check valves to prevent water backflow into the electrical generator. Failure to install these can create an electrocution or equipment damage hazard. As with any pool equipment, components should be UL listed or equivalent. Fluidra CMP's products, for example, are NSF 50 certified and designed to meet safety standards. Regulatory compliance. According to industry standards, ANSI APSP 5 and the Model Aquatic Health Code, ozone or AOP must be used only as secondary supplemental systems alongside a primary residual sanitizer. This means you must still maintain a minimum chlorine or bromine level in the pool water to meet health codes. Ozone and AOP are not standalone sanitizers. They are, however, recognized for improving water quality. The CDC and PHTA recommend supplemental systems, especially for high-risk or heavily used pools, to boost disinfection and reduce byproducts. Residential pools don't have specific ozone limits in most areas, but commercial codes often require that any ozone in the pool, water be under 0.1 parts per million at the return, which is usually the case naturally. It's wise to follow similar principles at home. Ensure the ozone output is tuned properly so no strong ozone smell is detectable at the pool. When used as directed, ozone and AOP systems are safe enhancements that meet relevant standards. Look for NSF/ANSI 50 certification, indicating the unit was tested for disinfection efficacy and safe operation. 5. Environmental impact and byproducts. Energy consumption. Both ozone and AOP systems run on electricity, but their energy footprint is relatively small. A typical residential ozone generator might use on the order of 50 to 100 watts, and a UV lamp of similar scale might use 40 to 100 watts. So an AOP that combines them could be around 100 to 200 watts in total. For perspective, this is only a fraction of the power draw of a pool pump or heater. Many pool owners run ozone AOP systems on the same schedule as filtration. With modern variable speed pumps, these can often run 12 to 24 hours at low speeds, meaning the ozone AOP might be powered for extended periods. Even so, the cost in the electricity is modest, perhaps a few dollars per month, relative to the benefit of reduced chemical usage. Some advanced systems further optimize energy by only activating the ozone arc when needed. For example, some units sense ORP or have cycles. The UV in an AOP stays on during operation, but UVC lamps are generally efficient and low heat. Chemical reduction and water quality. The primary environmental benefit of using ozone or AOP is the reduction in chlorine and other chemical consumption. By handling much of the oxidation demand, these systems allow you to use fewer chemicals. For instance, less frequent shocking with high doses of chlorine. This means fewer chlorinated byproducts end up in the environment, either through backwash water or splash out. Ozone itself reverts to oxygen, leaving no persistent chemical in the water. Hydroxyl radicals from AOP are short-lived and likewise do not remain to form residues. Consequently, pool water treated with ozone AOP tends to have lower levels of chloramines, trihalomethanes, and other disinfection byproducts that can be harmful to swimmers and corrosive to equipment. Another byproduct consideration, ozone can react with certain contaminants to form innocuous end products. For example, ozone will oxidize ammonia from urine or sweat into nitrate. Over time, nitrates can accumulate slightly, but this is usually managed by periodic water dilution and is far preferable to having ammonia form chloramines. There is a minor possibility of bromate formation if the pool has bromide ions from using bromine or some minerals, and ozone is applied, but in outdoor residential pools, this is typically negligible. Material and environmental footprint. Using an ozone or AOP system may allow a pool owner to avoid other additives like algicides, some of which contain heavy metals, since these systems also help control algae. With clearer water and fewer chemicals, there is often less need to replace water as frequently, conserving water in the long run. The equipment itself has some environmental footprint, manufacturing and eventual disposal of UV lamp, etc. But many components, like the plastics and metals in the unit, can be recycled or are long-lasting. The UV lamps should be disposed of as e-waste due to mercury. From an air quality standpoint, especially for indoor pools, reducing chloramine off-gassing by using ozone, AOP dramatically improves the indoor air environment, a health and environmental win. In summary, ozone and AOP systems strive to minimize harmful byproducts in pool water. By preventing chloramine buildup, they not only make swimming more pleasant, but also reduce corrosion of indoor ventilation systems and irritation to the environment. No more chlorine smell wafting from the water. The only notable outputs are oxygen and small amounts of CO2 from power usage. Pool owners focused on eco-friendly operation often find that investing in these advanced oxidation systems aligns with a greener, healthier pool maintenance approach. 6. Cost analysis. Upfront equipment costs. Ozone systems have been around longer and tend to be less expensive than AOP units. A residential ozone generator unit for a 20,000 to 30,000 gallon pool might cost on the order of $500 to $800. For example, the CMP DL Ozone 25 is listed around $600 to $650 online. AOP systems, which include both ozone and UV components, are more complex and usually priced higher, often in the $900 to $1,000 to $500 range for residential models. CMP's DEL AOP 25, rebranded as AOPS, lists for around $1,000, some retailers showing approximately $940 to $1,050. Component placement and larger AOP units can be more. When budgeting, one should also consider any optional add-ons. For instance, a Degas mixing vessel might add several $100s. CMP's MDV unit is roughly $500 if needed. Installation labor is another factor. If a professional is hired, expect a few hours of work. However, many handy pool owners can self-install these systems if comfortable cutting into PVC and doing basic electrical hookups, thereby saving on labor costs. Ongoing operational costs. On a day-to-day basis, ozone and AOP systems incur costs via electricity usage and parts replacement. Electrical cost, as discussed, is relatively small, perhaps $5 to $15 per month depending on local rates and runtime. More significant are the maintenance parts. For ozone, corona discharge cells might cost $100 to $200 when they need replacement, often every 3 to 5 years. Some newer units have longer life cells, e.g. CMP's APG cells are noted for extended lifespan. For AOP, you have the ozone cell plus UV lamps, approximately $50 to $150 per lamp. UV lamps typically are replaced every 1 to 2 years, so an AOP might have a recurring cost of perhaps $100 to $200 every couple of years for new lamps and ozone cartridges. If using an air dryer cartridge or oxygen concentrator, more common in larger ozone installations, there would be maintenance on those as well, but most residential systems just use ambient air. Chemical savings. A big cost benefit of these systems is reduction in chemical usage. Pool owners report using substantially less chlorine. For example, some find they cut tablet or liquid chlorine use by 50% or more when ozone AOP is running optimally. They may also save on shock treatments. An ozone system can in effect replace routine shocking because it continuously burns off organics that would otherwise accumulate. Over a season, this can translate to savings of hundreds of dollars on chlorine, especially if using costly formulated products. Additionally, with fewer chloramines and better oxidation, the water stays clearer, which might reduce the need for clarifiers or algicides. While exact savings vary, one can reasonably expect to lower ongoing chemical costs, partially offsetting the electrical and part costs for the ozone AOP unit. Longevity and long-term value. A quality ozone or AOP unit can last many years, often 5 to 10 plus years, with proper maintenance. The initial cost is therefore amortized over a long period. There's also an intangible value in protecting other investments. By reducing corrosive chloramines, these systems can prolong the life of pool heaters, covers, and even outdoor furniture near the pool. Less chemical outgassing. If the pool is saltwater, the salt chlorinator cell benefits from a lighter workload and can last longer. From a resale perspective, Having an advanced sanitization system could be a selling point, as buyers increasingly look for luxury or modern pool features that promise low-chemical, healthy water. Fluidra's notion of the complete modern pool is exactly chlorine, plus a second sanitizer, meaning such combos are becoming the expected standard in high-end residential pools. When comparing costs, pool owners should weigh the slightly higher upfront and maintenance cost of AOP versus Ozone against the performance benefits. AOP, while costlier, may provide greater chloramine control and pathogen kill, which might be worth it for those very sensitive to chlorine or concerned about maximum water purity. Ozone offers many of the benefits at a lower price. In either case, the consensus is that the water quality improvements and chemical savings tend to justify the investment over time. 7. Expert opinions and case studies. Industry and manufacturer insights. Pool industry experts widely acknowledge the advantages of both Ozone and AOP, often suggesting them as upgrades for a more enjoyable swimming experience. Fluidra's CMP brand has published extensive materials and earned NSF certifications for their next-gen AOP systems, underscoring that these systems achieve a 99.9% kill rate on key pathogens. Victor Walker, CMP's Director of Product Design, stated that AOP products are the most powerful products available to help pools stay healthy, noting they reduce chlorine dependency, kill contaminants, and clarify water. In 2020 to 2021, CMP's new AOP units became the first to be NSF 50 certified as supplemental sanitizers with a UV/ozone combination, meaning they passed third-party tests for 3-log 99.9% reduction of bacteria in pool water. This is a strong validation of their effectiveness. Aqua Magazine and Pool Pro have featured articles on the rise of AOP technology. An Aqua Magazine piece noted that hydroxyl radicals from AOP work millions of times faster than UV or ozone alone. Logically, and predicted AOP would become a standard addition as the industry shifts toward health and wellness priorities. The same article highlighted that the CDC recommends supplemental systems like AOP for every pool to improve water safety and chlorine performance. Pool owner testimonials. Pool professionals and homeowners often comment on customer satisfaction when using these systems. They immediately notice the lack of chlorine smell, better water feel, softer on skin and eyes, and easier maintenance with Ozone or AOP. For example, one homeowner with a CMP AOP unit noted the water was so clear it looked like a high-definition display, and that their chlorine usage dropped roughly in half, also advising to adjust pump speed to avoid any ozone bubbles. Another case study from a commercial pool, indoor, that installed an ozone system saw combined chlorine levels drop to virtually zero, and patron complaints of odor, irritation disappear. A dramatic illustration of ozone's impact on chloramines. While residential pools are usually less extreme, the same principles apply. It's also pointed out that UV-only systems, while good at inactivating microorganisms, do nothing for chloramine removal or oxidation of oils, etc., which is why Ozone or AOP is preferable when the goal is byproduct control. Overall, those who have added these systems to their pools often report they wouldn't go back to a traditional chlorine-only setup due to the improvement in water quality. Ozone versus AOP perspectives. There is general agreement that both Ozone and AOP are effective supplemental sanitizers, but some experts note that for many residential pools, a well-sized Ozone system already achieves most of the benefit at lower cost, whereas AOP might be considered overkill unless one desires the absolute best water quality. However, for those with sensitivities or seeking premium water clarity, AOP's extra boost can be worthwhile. Industry consensus is that adding either system will markedly improve a pool's water quality. The choice often comes down to budget and performance needs. Ozone is praised for its strong oxidation and cost-effectiveness, whereas AOP garners praise for being the cutting-edge solution that covers all bases, delivering the highest oxidation potential and fastest contaminant breakdown. Both have the backing of research and real-world use to show they reduce chemical use and enhance swimmer comfort. 8. Summary and recommendations. Comparative advantages, ozone systems, proven technology with decades of use, excellent at oxidizing chloramines and organic waste, resulting in clearer water and reduced chlorine demand. Generally simpler and cheaper than AOP. Installation is straightforward and maintenance is manageable. Occasional part replacements. Does not leave any harmful residual. Ozone decays to oxygen. Ideal for pool owners who want a reliable boost in water quality and less chlorine smell, without a very high upfront cost. AOP systems. Cutting-edge performance by generating hydroxyl radicals, the strongest oxidizer available for pools. Achieves even greater destruction of contaminants. Some systems claim 99.99% pathogen reduction, and virtually guarantees minimal chloramines. Particularly beneficial for those with heavy pool use or health concerns, e.g. wanting extra protection against crypto or other chlorine-resistant microbes. Combines benefits of ozone and UV. However, costs more and has a bit more complexity, UV lamp care, etc. AOP represents the premium choice for the ultimate in water, clarity, and safety. Key disadvantages. Ozone alone cannot inactivate certain parasites as effectively as AOP, which has UV light aiding it, so AOP may provide a broader disinfection spectrum. Also, ozone might slightly lower a chlorine residual if oversized or run 24/7 due to its strong oxidizing nature, requiring careful balance. AOP systems have higher initial price and multiple components to maintain. If not installed properly, e.g. incorrect flow rate or lack of Dega unit when needed, they can introduce fine bubbles or ozone off gas in the return line. Swing though, this is easily solvable with proper setup. Neither system eliminates the need for chlorine entirely, a fact sometimes misunderstood. You must still maintain a minimum chlorine level for residual protection at all times. General recommendations. Assess your pool's needs. Evaluate your pool's typical bather load and any water quality issues. If you occasionally notice chloramine odors or use the pool moderately, an ozone system will likely suffice to improve conditions. If your pool sees very heavy use, or if you have an indoor pool or family members with chlorine sensitivities, an AOP system offers the maximum level of oxidation and purification. Budget versus performance. If budget is a primary concern, a high-quality ozone unit, e.g. CMP's DEL ozone series, delivers most of the benefits at a lower cost. If you can invest more for top performance, an AOP unit, like CMP's DEL AOP line, provides the absolute best water quality. These were the first NSF 50 certified UV/ozone combos on the market. Either way, stick to established brands within the Fluidra family to ensure compliance with safety standards and reliable support. Professional installation. Consider having the system installed by a pool professional or follow manufacturer instructions closely if DIY. Proper placement in the plumbing, correct injector sizing, and integration with the pump automation are key to performance. Ensure any needed accessories, check valves, flow switches, degauss vessel for AOP if recommended, are included. Maintain your chlorine residual. Continue to maintain a normal low-level chlorine residual as required. Think of ozone AOP as assistive technology that handles the heavy oxidation work, while chlorine, or another sanitizer, remains the constant background disinfectant. This combination will meet any pool safety standards and keep water microbiologically safe. Monitor water chemistry. After installation, monitor your pool's free chlorine and combined chlorine levels. You should see a drop in chlorine consumption and consistently low combined chlorine, often 0 parts per million. Adjust your chlorinator output or dosing to the new lower demand. Also check that pH and other parameters stay in range. Ozone has minimal impact on pH, but strong oxidation might slightly lower alkalinity over time. With less chemical input, you may find the water balance stays more stable. In conclusion, both ozone and AOP systems are excellent enhancements for residential pools, yielding superior water quality with fewer chemicals. Ozone offers a cost-effective, proven method to reduce chloramines and chlorine usage. Зрение, while AOP представляет следующий уровень, практически исключая побочные продукты и максимально увеличивая мощность дезинфекции. Prioritizing a reputable brand, such as CMP under the Fluidra family, ensures the equipment meets industry standards and performs as advertised. For most outdoor pools, an ozone generator will provide clear benefits and a noticeable improvement in swimming comfort. Those seeking the ultimate in pool water purity and minimal chemical presence can confidently opt for an AOP system. In either case, pairing the device with a modest level of chlorine will keep your pool safe, sparkling, and enjoyable, with much less of the chlorine hassle than traditional treatment alone.